Hello guys, welcome to another video. Today we're going to work at topic 6 and we're going to solve a couple of multiple choice questions. So without further ado, let's start working with the problems and the solutions. Number 1, it says a mass is suspended by a string from a fixed point. The mass moves with constant speed along a circular path in a horizontal plane. The resultant force acting on the mass is zero directed upwards, directed towards the center, and so on. So first of all, we need to create here a free body diagram and see what are the resultant forces. So what we have here, of course, we have the weight, it's all the way down, and then we have also the tension from the string. And these are all the forces that I have. Now the tension of the string, it can be resolved in the two different components of Ty and of course Tx. And you can see from here that Ty, it must be equal with W, so otherwise we will have motion up and down in the y-axis, but we don't. So the only force is Tx. So the only force here is directed towards the center of the circular path, so number C. Number 2, which single condition enables Newton's universal law of gravitation to be used to predict the force between the Earth and the Sun? Well, we know that the gravitational fields are defined using the idea of small test masses. So, of course, the Newton's universal law of gravitation combines all these things, and also we need only to have the Earth and the Sun to behave as point masses. The rest of them they apply, but they are not relevant with the application of the law. Number 3 is the same, so let's move to the number 4. It says an electron moves with uniform circular motion in a region of magnetic field. Which diagram shows the acceleration A and velocity V of the electron at point P? So we know first of all that acceleration in a circular path it's always inwards the center of the circle. So it's the centripetal acceleration, so it cannot be C or D. Also, we know that the velocity is always tangent to the circumference of the circle, so it cannot be A. The only correct answer here, of course, is B. Number 5, it says that a planet has half the mass and half the radius of the Earth. What is the gravitational field strength at the surface of the planet? The gravitational field strength at the surface of the Earth is 10 newtons per kilograms. So what we have to do here is to work with this formula for the gravitational field strength, that is G times the mass over the r square. Of course, here it applies for the mass of the Earth, the radius of the Earth, so it's the gravitational field strength of the Earth. And this is 10 newtons per kilogram. Now your new gravitational field that you're trying to find of the other planet, it has half of the mass of the Earth and half of the radius of the Earth. So if you will solve here, you are going to have the mass of the Earth divided by 2 divided by the radius of the Earth squared divided by 4. And if you keep doing the math here, you're going to find 2 times G, the mass of the Earth, over the radius of the Earth squared. So you see here that your new G, it's 2 times the G of the Earth. So 2 times 10, it gives you 20 newtons per kilogram. Number 9, the magnitude of the potential at the surface of a planet is V. What is the escape speed from the surface of the planet? Now what we know, first of all, we see for number C and D that it has another term of R, the radius, but the R is not defined here. So this cannot be the correct answer. C and D are incorrect. Now, in order to find the velocity, the escape velocity, we need actually to equalize the kinetic energy with the gravitational potential energy. Now, kinetic energy, it's given by that, mv squared, is equal with the gravitational potential energy, whatever it is. Now, if you want to solve here for V, your result is going to be the square root of whatever, but also you will have this factor 2 that is going to multiply this term. So it cannot be A, the correct answer is B, because you want this factor of 2 to multiply your answer, the potential actually at the surface of the planet. Number 10, two particles, X and Y, are attached to the surface of a horizontal mounted turntable. The turntable rotates uniformly about a vertical axis. The magnitude of the linear velocity of x is v and the magnitude of its acceleration is a. Which of the following correctly compares the magnitude of the velocity of y and the magnitude of the acceleration of y with v and a respectively? So now what we want to do is to figure it out what's the difference between y and x in velocity and acceleration. So let's start first with velocity. The velocity, let's see, the x, it moves in this circle at a specific time. The y, it moves in this circle, a bigger circle, at the same time. So the y, it crosses more distance, and at the same time, of course, the velocity of y, it's bigger than the velocity of the x. So it can be either b or d. Now we need to figure out what is happening with acceleration. Acceleration, centripetal acceleration, is v squared over r. Now we cannot really work with this formula because we don't know velocity, we don't know r. We know that they are bigger, but this is square also, so it's a little bit complicated. What I can do is to substitute the velocity with this formula. So acceleration now it's omega squared times r squared over r. So you have this relationship for acceleration, omega squared times r. You see that the omega squared, of course, it's constant, and you see that a and r, they're directly proportional. So bigger r for y, bigger radius, so the acceleration of the y, it's also bigger than the acceleration of x. So it can be either C or D, and correct answer here, of course, it's D. Number 13. An object rotates in a horizontal circle when acted on by a centripetal force F. What is the centripetal force acting on the object when the radius of the circle doubles and the kinetic energy of the object halves? So now, what we need to do here is to find the difference between the centripetal force that you had initially and the new centripetal force that you're trying to find now with a new velocity and a new radius. Now the radius, we know that it doubles. This is the easy part. We need now to see what the velocity does in terms of kinetic energy to be halved. So if you solve the kinetic energy formula for the velocity, you're going to take this relation, 2 times kinetic energy divided by the mass. Now what you want to do in your new velocity is to halve the kinetic energy. So 2 times kinetic energy halved divided by the mass. So you see here that you have the relationship of kinetic energy over mass. Now somehow you need to create this formula here, this relationship in here, so you can compare it. And the easiest way to do is to multiply the numerator and numerator with 2. So 2 times the square root of kinetic energy over mass. So what you have here, the square root of 2 can go inside here. So you have 1 over the square root of 2 times the square root of kinetic energy over the mass times 2. And all this part is the relationship of velocity that you had before. So your new velocity now, it's the old velocity divided by square root of 2. And now I'm going to apply here in my new centripetal force these relationships. So you have velocity over square root of 2 square divided by 2 times the radius, because the radius is doubled. So from here, if you do the math, you have mass times v square over 2 divided by 2r. So from here you have m v square over 4r. So that means that you have force, the previous force, divided by 4. And this is, of course, the answer A. Number 14. What is the definition of gravitational field strength at a point? So this is a theoretical one. Of course, we know that the force acting per unit mass on a small mass placed at a point, it gives you the definition of the gravitational field. You can check that at page 259, topic 6, and find there the definition. Number 15 is the same as 13, so printing mistake, let's skip this one. And now we have number 16 that it says, a body moves with uniform speed around a circle of radius r. the period of the motion is t. What is the speed of the body? Now, of course, we're looking for speed, so it is the distance divided by the time. Now, the distance, we can take the distance of a full circle, so it's the circumference of the circle, 2 pi r, divided the time that it needs to complete one circle, it's period, one period, so it's capital T, so it's pretty obvious here, it's A. And number 17, the force F between particles in gravitational and electric fields is related to the separation R of the particles by an equation of the form F is equal to ABC over R squared. Which of the following identifies the units for the quantities A, B, and C of a gravitational field? Okay, so now what we know here is that the force, it is G times the product of the masses of the two different objects divided by their distance squared. So pretty obvious that G is the A here and B and C are the masses. So B and C, it can be kilograms. Now what is G? G, it has units of newtons times meters square per kilograms. You can see that in your data booklet, you have the constant there with the units, of course. Otherwise, here you need to have the units in the end that it will give you force, so you need everything to cancel out the other part as meter square for the distance, kilograms square here for the masses, and newtons, of course, in order to have the force. So it's either C, either D, and the only answer here for you, it's number D. So that's it for today, guys. You need to study hard and good luck.